Today I am going to discuss time value of money. The very common formula for compounding is this: Pn is equal to A into 1 plus R to the power n, where A is equal to present value, R is equal to rate of interest in number of years for investment, Pn is equal to the amount which will be received after n years after investment. The rate of interest, say per annum. This is the formula for periodic compounding. Periodic means periodical compounding. Say annually for 1 year, half yearly after 6 months compounding, quarterly after 3 months compounding, monthly, it may be even weekly compounding. A simple example is given here. Suppose you have invested rupees 1000 at an interest 10% per annum. How much you will receive after 1 year? Put the values in this formula. The present amount you are investing is 1000. Rate of interest is 10%, means 0.1. N is 1 in this case, because after 1 year. Hence the value you will receive after 1 year, that is P1 is equal to present value 1000, 1 plus 0.1 to the power 1. And the value will be rupees 1100. If you get rupees 1100 after 1 year, and the rate of interest prevailing in the market is 10%, its equivalent value today is rupees 1000. That is also shown by this example. If you receive 1100 after 1 year and the rate of interest 10%, what will be the value of money today? So you have to find out, in this case, the present value. P1 is given 1100, that is the amount after 1 year. R is the interest rate, that is 0.1. Power is N is equal to 1, that is 1000. Okay. Another example. The number is wrongly written. It is example 2, not 21. It is just mistake. Suppose you have invested rupees 1000 today at the rate of 10% for 2 years, not 1 year. How much you will receive after 2 years? Again, you have to put the value to this compounding formula. Pn means P2, that means the amount you will receive after 2 years. Present value, you are investing rupees 1000, rate of interest 0.1 to the power 2, and the amount will be 1210. You can calculate it, then you will get this value. Through timeline it is shown here. That means you are investing rupees 1000 today at this 0 time. After 1 year you will receive 1100, and after 2 years you will receive this amount if the rate of interest is 10%. Conversely, in the reverse way, you can say if you receive 1200 and 1210 after 2 years, the present value will be rupees 1000. And if you receive 1100 after 1 year, it's equivalent to the amount at present is 1000. This tool is very useful for investment decision making. One area is capital budgeting. You will see later on when we discuss in that chapter. In capital budgeting, for any project, there are different investment in different points of time, and the project will give you the inflow of cash or inflow of money at different future periods. You may convert all the values to the present value today. And what you will do, you will sum total all the outflows, that means invested to the project, and you will sum total all the inflows you will get from the project to the present value, because you are taking decision today and then compare it. If your total investment values at present is more than the present value of cash outflows, then we invest to the project. That is, you have some opportunity or return on this project. For that purpose, this tool is very important. Though it is very simple, but it is very important. Next. Example 2. What would be the present value if you receive rupees 1,210 after 2 years? The existing rate of interest is 10%. That means you are receiving this amount after 2 years. That just now I have discussed. In this case, we are going to find out the present value. The present value will be this, the present value, a PN, you are receiving 1,210, rate of interest 0.1 per annum, and N is 2. This sign is power. If you put in the formula, then you will get this amount that I have already shown you. That means if you get this amount at this point, it's equivalent to rupees 1,000 at this point. The present value will be 1,000. Now, we are taking another example. This is another example for decision making. Suppose today you have given rupees 3,500 to your friend. He proposes to return the money to you as rupees 2,000 after 1 year, rupees 1,000 after second year, and rupees 1,000 after third year. The prevailing interest rate or bank rate is 10% per annum. This is 10% per annum. Should we accept this proposal? That means you will be gainer or loser. Okay. And accordingly we will take decision. And this is the timeline. For this problem, this is outflow of fund. You are giving this money to your friend, and outflow is indicated by bracket, within bracket. And this is inflow. You will receive from your friend. After 1 year 2,000, after 2 year 1,000, after third year 1,000. How you take decision? This is the present value we are investing today. That's why it is not required to find out again the present value. At this point, we will calculate what is the value of this future inflows of fund or amount. That means you have to convert this amount to present value today. This amount to present value in this way. See next. This is present value of 1, P1. This is 2,000. After 1 year, you are receiving this. Interest rate is 1.1 and power is 1. The present value is 1,818.18. That means if you receive 2,000 after 1 year, it's equivalent. You are getting this money at present if the rate of interest is 10%. Conversely, if you invest this amount today, after 1 year at the rate of 10%, you will get 2,000. Clear? Now, convert 1,000 which you are receiving after 2 years. What is the present value? Today, after 2 years, you are receiving 1,000. The rate of interest 0.1. This is 0.1. So for 2, if you calculate it, you will get this amount. This is the present value. And after third year, you are receiving 1,000. What is the present value today? 1,000 divided by 1 plus 0.1 to the power 3. This is this. After third year, you are receiving 1,000. That means it's equivalent. You are receiving this amount today. Then what amount in total you are receiving from your friend today? Means present value. You add this plus this plus this. All these you are receiving. All these are cash inflows at present value. Then you will see this is the total amount at present value you will receive from your friend. But what amount you have given at the present value? 3,500. You are receiving at present value less than you are giving to your friend. That means you are in loss. You should not go with this proposal. You will be in loss of rupees this. This is negative loss. Now suppose you have changed the proposal. If your friend is ready to return you rupees 2000 after second year and other payments remain same, then what will be the status? Here I have shown in the table form, the same thing in the table form to make it easy to understand and for application also. So year-wise cash inflows after 1 year 2000 revised offer, after second year this is also 2000, and after third year you are receiving 1000. Total amount you are receiving 5000, but you will not take decision by the total amount. You have to find out what is the present value, because the time value of money is applicable here. First, 0.909, this is the discounting factor. You can say discount factor means 1 by 1 plus 0.1 to the power 1. If you calculate 10%, then you will get this amount. That means 2000 is inflows and this is the discount factor. If you multiply this with this, then you will get the present value that I have written here. The discount factor for this case, that means 1 by 1 plus 0.1 square, you will check it, will be 0.826. There is a table also, you can get the value readily available from the table, but it is better you practice it, and it is very easy to calculate through your calculator, even manually, or minimum number of years. So this is the discount factor, and if you multiply this, then you will get this. That means this is the present value of this amount which you are receiving after 2 years. And what is the present value for this 1000? This is the discount factor. 1 divided by 1 plus 0.1 to the power 3. This is the discount factor. If you calculate, then you will get this factor, and the present value will be this. That means the present value 751.31. If you invest in a bank after 3 years at the rate of 10%, you will get rupees 1000. That means receiving 1000 after 3 years equivalent to the present amount as this. And if you add all this, then you will get the total amount you will receive at present value, which is 4222.1, which is more than your investment. That means you have given to your friend. This is your surplus. That's why you can go ahead with the proposal. This is the use of time value of money. Only by seeing the magnitude, you can't take decision, because with the passage of time and with the rate of interest, the value changes. That we have shown here. 2000 receiving after 1 year means you are receiving this amount today, because you are taking decision today. If you not convert this to the present value, then it will be difficult to take decision. This is the use. Okay. Now we are going to discuss this present and future value in the case of continuous compounding. Continuous compounding. This is very useful in different situations. Basically, in the case of option valuation, the derivative product, you will see the value of option dependent on underlying assets, says shares. The value of share is changing every moment. It will not wait for 6 months, 1 year for change the value. That's why in that case, to find out the value of option, this type of compounding means continuous compounding is useful. To get the idea, see the formula of periodical compounding I have already discussed. This again is repeated here, but this is your periodic compounding. This is, say, annual compounding. Now in the case of half yearly compounding, how the formula will be changed? Suppose the compounding is half yearly, means after 6 months, not after 1 year. Then the formula will be changed in this way. Rate of interest, which is rate of interest per annum, divided by 2, as it is half yearly. You convert it annually divided by 2, and the n to be multiplied by 2. Because in a year, there are 2 parts, after 6 months and then 6 months. For quarterly compounding, 4 parts. That's why you divide R by 4 and multiply N by 4. In this way, by applying the formula, you can find out the future amount received, what was the period of compounding. If the period of compounding is M, it may be weekly, it may be daily, like that, then R divided by M is the period, into M into N is the number of years. This is the general formula. Now, if M tends to infinity, that means it's very small, like that. It tends to infinity, weekly, daily, hourly, like that. If it is continuous, M tends to infinity means as if compounding is like that. It is a continuous compounding. The formula will be changed in this way. Pn is equal to A into e to the power Rn. N is the number of years, R is the annual interest rate, and E is the exponential constant, the value of which is this, and A is the present value. How the formulas come, that is a mathematical part. I am not going to discuss in detail. Only you should know, in the case of continuous compounding, when the value is changing every moment, then you should apply this formula. Okay, I am going to discuss through example. First, suppose you will receive 50,000 after 2 years. Then what will be its present value? If the interest rate is 10%, though I have already discussed, but for better understanding, I have again repeated the discussion. Present value, after 2 years, you are receiving 50,000, 1 plus 0.1 square, that means this amount. Okay. This is the amount which is considered as the present value. In continuation of the above problem, what will be the present value if the interest rate is quarterly compounding? Interest rate is quarterly compounding. Quarterly means 4 part. After every 3 months, it is being compounded. Then what will be the amount? Pn is equal to A present value into 1 plus Ry divided by N. This is the power, 4 into M. Just now I have discussed. Here I have discussed the formula. This is the application only. The Ry 4 to the power 4n. Interest rate is 10% given. If you compute it, the value will come to this. You can check the value. This value will be higher than this. What was this? 41,322. And as it is a present value, that's why more quickly it is being compounded. That's why the present value will be lesser, but the future will be more if the compounding is faster. So quarterly, if the quarterly compounding the same amount, the present value is this. That means if this amount is invested at the rate of 10% per annum, the interest rate will be quarterly compounding. Then after 2 years, you will receive 50,000. This is the present value. Now, this is important. Find out the present value of the same problem in the case of continuous compounding. What will be the present value in the case of continuous compounding? Pn is the value after n year. In this case, it is given 50,000. You have to find out A, present value. The rate of interest is given 10% and n is 2. That means the formula will be like this. Present value A is equal to Pn 50,000 divided 1 by, that's why if you put it in this way, then it will be e to the power minus 0.1 into 2. And this is the factor. The value of this, you can get it from the table that I will show you. The value will be 40,936.50. The table, in this way, will get table. This is the value of X and e to the power minus 6. E to the power minus 2, the value will be this 0.81873. So the value will be this present value. That means if you invest this amount today, in the case of continuous compounding at the rate of 10%, after 2 years you will get 50,000. Okay. Now this is the table. So this is all about your time value of money and how it is used in the case of continuous compounding, and the formula for finding the value in the case of continuous compounding has been discussed. Thank you.